Hi, everyone, and welcome to our webinar, What's New in Amazon Aurora. My name is Yoav Eilat. I'm a Senior Product Manager at AWS, covering Amazon Aurora and Amazon RDS, Relational Database Service. And the main goal of this webinar is to tell you, as people who mostly know Aurora already, what is new as of the end of 2019. At this point, we're after our major reInvent conference in Las Vegas, and I'll recap some of the things that we announced either at reInvent or a little bit earlier in the past few months. So here is the agenda for today. I'll do a very quick Aurora intro, assuming that most of you are already familiar with this service. I'll talk about global database and multi-master, what's new in these two features. Talk about the RDS Proxy, which was announced at reInvent as a preview. And it's a feature that supports several database engines, including Aurora. We'll talk about Aurora Machine Learning, which was also announced just a few weeks ago, and other recent announcements from the past few months. So let's start with a quick overview of Aurora, for those of you who maybe have heard of it, maybe are not using it. So Amazon Aurora is a relational database in the cloud. It's a database that you can start with just a few clicks in the console, the AWS console. It's delivered as a managed service, meaning that there's nothing for you to set up, to install. It provides the speed and availability of high-end commercial databases, but with the simplicity of open source databases. So Aurora is based on two popular open source databases, MySQL and Postgres, and it offers drop-in compatibility with those databases. So basically, any application that you wrote for MySQL or for Postgres will run with no modifications on Aurora, your choice of whether you want MySQL or Postgres compatibility. And like with anything in the cloud, you have very simple pay-as-you-go pricing. You pay only for what you use. You pay as long as you run the database. When you shut it down, that's when you stop paying, and you pay for the instance of the database that you're running, plus for the storage and the networking resources that you use. So no commitment, and you can just run it as a cloud service very easily. So some of the benefits that Aurora provides, compared especially to running a database yourself, is that you have performance and scalability, high-end commercial databases, and it provides up to 5 times the throughput of standard MySQL databases and up to 3 times the throughput of standard Postgres. You have the option of adding read replicas for read scaling, so up to 15 read replicas, which share the storage with your main, with your primary instance. We'll see that in the next slide. Availability and durability, lots of capabilities around fault tolerance, self-healing storage. The storage is highly durable, and using our availability zones, which are standard AWS concept, and continuous backup so that you don't need to do any backups of the database yourself. The database is continuously backed up to Amazon S3, and you can do point-in-time recovery to any point that you want for as long as you keep the backups. Lots of security capabilities at the network level in terms of encryption inside the database at rest and in transit between your database and the application. And lots of capabilities around authentication and authorization of users. So everything is highly secure. And as we said, fully managed. You don't need to take backups. You don't need to do upgrades. You don't need to do patching. It's fully managed as a database service in the cloud. A few more words about the storage layer of Aurora. So that's one of the main differences between Aurora and a standard MySQL or Postgres database, is that Aurora has a purpose-built storage system. And the storage system is what we call a log-structured storage system, meaning that the data is stored as a set of logs plus a set of blocks or pages that the database can read. So as you make changes, as you make updates and inserts into the database, all of those changes are stored as logs. And that means that we overcome many of the problems that other database storage systems have with block storage or file storage. They have different drawbacks, and here it's a storage system that was purpose built for how databases work. the storage is in 3 availability zones, meaning 3 locations that are in the same region, they're close to each other so that we have low latency connections between them. And your data is stored twice in each availability zone. So that means that there are essentially 6 copies of your data being stored, which makes your data very durable. It's very, very unlikely that all 6 copies of the data will get damaged. Maybe it could happen, disks can fail, things like that can happen, but probably not 6 times. So your data is very safe and durable. And in terms of availability, the system is built to survive or to stay up in the case of an availability zone +1 failure, meaning that if we have 6 copies here and 2 of them, let's say that availability zone 1 goes down, which is highly unlikely in itself, but let's say that happened, plus 1 more copy in one of the other availability zones, so 3 total, you would still be able to read from your database even in that scenario, which is unlikely to begin with. So high durability, high availability, and it's a very good option for anyone who needs a MySQL or a Postgres database or wants to migrate your data to those databases. So that was a very quick overview of Aurora, and let's jump into what is new in the last few months. So we'll start with Global Database and Multi-Master. Global Database has been around for about a year, and it has some new capabilities that were recently announced. So let's talk a little bit about that. So Aurora Global Database, as the name implies, it's a way of deploying your database into multiple regions. So basically, your database has a primary region, which we see in this example in Ohio. And you can see that we have a master, which is the red one, plus 2 read replicas. Of course, in this example, the read replicas and the master are sharing the storage in Ohio. And we are running outbound replication behind the scenes to 3 additional regions in this diagram. And that means that you have fully replicated and up to the second copies of your data in these 3 additional regions. So basically, it's a global deployment of the database. So there's 2 main reasons why you would want to do this. One is for faster disaster recovery. So if you have any kind of failure or connectivity issue in the primary region, you can very quickly recover in one of the other regions, and you can trigger that very simply, and now you are fully operational. You turn the other region into the primary region. That would be where you would start writing from that point. The RPO, or replica lag, is usually less than 1 second. So you have data which is, in most cases, not more than 1 second old. So very easy to recover, and your data is up to date. So the second reason that you would probably want to run this is for what you could call enhanced data locality, meaning that you can serve read transactions in those other regions locally. So if I have lots of users in Europe or Ireland in this case, which would be closer geographically to my European users, I might want to replicate the data there and run a copy of my application in Europe somewhere, maybe in Ireland as well. And that way it can get local reads, and users in that region would get much faster performance. So typical thing to do would be to spread these out around the world. You might want to put, for example, if you're in the for US users, maybe one on the East Coast and one on the West Coast, maybe one in Europe, maybe one in Asia, maybe in a few other places, depending on where your customers are. And that way they get fast local reads in all of those regions. So what is new since last year is that global replication now supports up to 5 secondary regions. So I can have my primary regions and up to 5 of these additional regions, and all of them will get the data replicated with a replication lag of less than a second, again, in most cases. And second thing that we added is in-place conversion. So in the past, you had to choose ahead of time whether you want a global database or a regular regional database. So when you created a database instance in Aurora, that was a choice that you made. Now you don't need to choose that up front anymore. You can just create a database, and if you want later on, you can say, okay, I want to add another region to my database. I want to turn it into a global database by adding, Northern Virginia to my Aura database, and now I have basically an in-place conversion to be a global database. So those two things were announced in November, so just a few weeks ago, as of this webinar. And a third thing that I should mention is Aura MySQL 5.7 now also supports global database, which was not available before. So now you have a choice of basically all of our Aura MySQL versions. They can use global database with in-place conversion and with replication to up to 5 secondary regions. And I should also mention that the recovery, in the case of disaster recovery, if you're doing a recovery, what you need to do is to turn one of the other regions into the primary region. You need to set up the writer there, and that takes less than a minute. So very good solution for anyone who wants to have high availability and quick recovery and quick reads globally. Okay, second topic in this category is multi-master. So this got announced in the third quarter of 2019. Let me do a recap for those of you who missed that announcement. So multi-master allows you to have two writers in the same region. So basically, you would have in a given region two masters, and both of them are writing to the same storage system, to the same storage layer of Aurora. And you can set up endpoints for each of them, and your application can write to either of these endpoints as you choose. The main reason that you would want to set up multi-master is for continuous availability, so that if for any reason one of these masters goes down, it will be much quicker to switch over to the other master and continue to write to the database. Now, it was always true in any Aura database that if the master goes down for any reason, you can take one of your read replicas and turn that into the master, but that takes longer, something on the order of 30 seconds, because we need to turn a read node into a writer. In this case, since both of them are already writers, then if one master goes down, and again, I'm talking about it just as a potential scenario, it doesn't mean that it's necessarily likely to happen. But if it happens, databases can go down, systems can fail. So that means that you can switch to the other master in just a few seconds, and that is good for applications with higher availability requirements. So the way it works, how do you use Aura Multi-Master with your application? So basically, every write that you do, you can see the app here will write to one of these endpoints, either writer 1 or writer 2 in this example. And then writer 1 and writer 2 will write the data to the storage layer. So what you would want to do in your application is obviously check that the writes actually succeeded and that the writer nodes are still responding. If they're not responding, if one of them is not responding, then you would want to start writing to the other one. But the rest of the time, you would probably want to distribute your writes more or less evenly, or as evenly as you can, between these two writers that you have that both go to the same storage. Both of them essentially do the same thing. They write to the same tables, they write to the same pages, but by balancing between them, you can get better performance, and that's what you would want to do most of the time. And you can use the same client-side drivers that you use with MySQL or with your original or existing Aura database. You can use them with multi-master, and they will work in the same way. So let's see what happens when both of these writers try to write to the storage layer at the same time. So obviously, one thing that could happen in theory is that you would have a conflict. So first of all, let's look at an example with no conflict. So I have master 1 and master 2, and each of them is writing to the database, but they're writing to two separate tables. So if they're separate tables, they're probably also writing to separate pages. And one of them is writing to page 1 and the other to page 2. And you remember that we have 6 copies of the data. That's why we can see that each of these pages, page 1 and page 2, is written to the storage layer 6 times, and we don't have any problem, and we don't need to do any conflict resolution because there's no conflict. These are 2 separate pages. And probably the easiest way to avoid conflicts is simply to divide your work between those 2 writers based on the table. So if each table is being written by a different master, then there are probably not going to be any conflicts. Otherwise, let's say that we did have a conflict. So here, both of these transactions, or T1 and T2, are being written to these two masters. And let's say that both of them are trying to update page 1 at the same time. So that still doesn't necessarily mean there will be a conflict, because the data that you wrote is not necessarily on the same page. But let's say that it is. So Aurora Multi-Master can deal with that situation. And what it does is basically the first one that succeeds is the one that is committed. So the way that the storage layer works is that as soon as we get an acknowledgement from 4 out of 6 storage nodes, that means that that transaction is considered committed. And even if the 2 other ones don't receive the data right away, they'll receive it between those nodes. So either they'll receive the request directly, or they'll complete the data from the other 4 nodes. So if, in this example, master 1 gets a response from 4 storage nodes before master 2 does, it means that transaction 1 is achieves quorum, as we called it. It gets 4 out of 6. And that means that transaction 1 is committed, and transaction 2 will fail. So that's simply like any other failure. Database returns. I mean, the application will get back the result that the transaction was not written, and now maybe it wants to try it again or do any kind of other error handling as appropriate for that application. So essentially, the storage nodes act as the arbitrators for these conflicts. As soon as one of them gets committed with 4 responses from the storage nodes, it means that that transaction succeeded, and any other transaction that conflicts with that will fail. But again, you don't really need to get into this situation too often. If it happens that you have a conflict, it's fine. The error handling will be correct, but the cleanest way is just to try to avoid it in the first place by just sharing the load between those 2 masters and writing separate tables and separate pages to those 2 masters. The next topic on our list is the RDS Proxy. RDS Proxy was announced just now at reInvent 2019 and going into preview. So the proxy is probably quite similar to other database proxies that you are familiar with and you might already be using. And they are needed by many applications, whether they're serverless or not, that open a lot of database connections and then they start to exhaust the resources of the database that you're using. So in an application, you might have thousands of database connections, if not more than that. And it's sometimes hard for the database to keep up with that amount of connections. You need to do, in addition to that, you need to deal with failures that could happen when you write with that kind of high throughput. And you might also want to take advantage of having some kind of proxy that sits between the application and your database in order to achieve other things. So in addition to dealing with a high number of connections, there's more things that a proxy can do. One thing is to deal with failures. For example, availability problems of the database. You can add security capabilities to a proxy, and altogether, it gives you higher availability, security, and throughput or performance compared to just the application talking to the database directly. So traditionally, proxy servers had to be managed on your own. Some people are running database proxies on EC2, for example. So they're running on AWS. They might be using our managed RDS or Aura services, but putting in a proxy on EC2, which you would have to manage on your own, and to do upgrades and to find the right instance size for that and all of that. So that makes it a little bit difficult to deploy. We wanted to make that easier so that it's just another option that you can choose as you're using the RDS or Aurora services. So the RDS proxy was just introduced, and it's a fully managed proxy as RDS is itself, and it does a few things. So first of all, it does connection pooling, so you can share a high number, you can have a high number of connections going from your application to the proxy, which will pool or reuse and multiplex a smaller number of connections going to the actual database instances running behind the proxy. It increases application availability and reduces database failover times, because even if the database were to crash, then the proxy could still be up and could still hold the connection to the application, so the application doesn't have to deal with error conditions. There's some security capabilities in the proxy that we'll talk about around passwords and access controls. And most importantly, it's fully compatible with your database. So the application talks to the proxy just as if it were the database, the MySQL or Postgres database, and it's completely transparent to the application. So currently, the RDS proxy is available in 5 regions, which you see listed here. And these regions, as you can see, cover every region of the world. And of course, it'll be rolled out to the rest of the AWS regions later on. It supports, at this point, MySQL engines. So both Aurora and non-Aurora open source MySQL running on RDS. And RDS and Aurora for Postgres versions are in development, and they're coming soon as well. So basically, this will cover both of these open source databases, whether Aurora or just plain open source. Okay, so the way it works, which should be quite familiar from other database proxies, is that the client application can open a database connection and do a transaction. One typical way that would happen is through Lambda functions. So that's a very good example of where you might have high connection counts, where you're calling Lambda many times, and each time the Lambda function is writing a record into the database. And that means that each of them will try to create a connection to the database in order to write something. That would push up your connection counts, and it would be a high throughput scenario. So that's a perfect example of when you might want to use the RDS proxy in front of the database, which would then pool the connections to a smaller number of connections to Aurora behind it, manage failovers. So if Aurora, for any reason, had an availability problem, those connections would be held by the proxy, between the proxy and the application, and provide the improved security. So the improved security works through 2 AWS services, IAM, Identity and Access Management, and Secrets Manager. We'll talk about that in just a minute. So connection pooling pretty much does what it says, shares a larger number of connections between the application and the proxy, as with a smaller number of connections going from the proxy to the database. And one of the things that we do is to detect session states that cause pinning of a connection to the database. So what might happen is that if your application sets certain states in the session, certain system variables, or other types of database options, it means that it makes it harder for us to reuse that connection to the database between that session and some other session. So if that happens, we will detect that situation and we will not share it until that connection is done, or whether that connection closes or the database, the application finishes that action, and then we can share that connection again. So those types of scenarios are detected so that we don't have basically any difference in the behavior of the database, whether you're using the proxy or not using the proxy. Similar thing we can say about availability and about faster failovers. So the application connections, as I said, are preserved during failover. even if the databases that you see on the right side, the red and blue databases, fail, it doesn't mean that the connection between the application and the proxy needs to fail. And another advantage is that we don't need to look up if the database fails, we don't need to look up the address of the new database instance, and the application doesn't need to know because the proxy still stays in the same location. So that basically saves us the need to do a DNS lookup, and that means that the failover time is much faster. In many cases, up to 66% faster failover compared to not having a proxy. So it's definitely also recommended for that reason. And finally, let's talk a little bit about security and how the proxy can help with that. So we integrated identity and access management, IAM, and made that mandatory for applications that want to connect through the proxy because it's a safer way to manage security. The best thing about it is that you don't ever put the passwords directly in your application code. So in the example that you see here, the application is creating a connection, but what it's doing is it's basically going to IAM and it's getting a token instead of having the password embedded directly into the application. So you'll see that when we create the when we do the MySQL.create connection, we're passing password : token, which is a token rather than an explicit password. And the RDS proxy will refuse to connect if you actually try to pass a password in plain text. So that that helps you to avoid having the passwords directly in your code, and it helps you to do easier password management because by getting the password externally through IAM, you can do things like rotating passwords, and all of these things will work out of the box rather than you having to manage them. So as soon as you give the token, the RDS proxy will go and retrieve the actual password from a service called AWS Secrets Manager. And that way, the passwords are all stored in a safe place, which you can control, which you can set policies on, and you don't have those passwords directly in your application. So you can see that in the screenshot above, we're saying that only IAM authentication is allowed in this case, and you're not allowed to pass passwords directly to the database. Next topic on our list is Aurora Machine Learning. That was announced also just a few days ago, just before reInvent started. And Aurora Machine Learning, as the name implies, is the ability to run machine learning on the data that you have in Aurora. So as you might have seen, if you try to integrate machine learning into your applications, it's sometimes hard to get data from your database into machine learning services. So there's a lot of machine learning services available in the cloud, but the question is, how do you get your data into those services if your data is sitting in a relational database? That can mean many steps in many cases. So we counted at least 6 steps that a typical application would need to do in order to get data and to run and to get predictions on data that you have in a relational database. So typically, and this is the old way that you would need without a capability like this, is you would need to, first of all, train your machine learning model. If you don't yet have one, maybe you already do. So in that case, you can skip step 1. So let's assume that now you have a machine learning model or algorithm available. You would need to write application code that would read the data from your database. You would need to do that in your application. You would need to format the data in a format that the machine learning model can read. And different machine learning models read data in different formats, sometimes JSON, CSV. Even if the format is known, sometimes the specifics are different, the columns are different. So you need to format the data to fit the machine learning model that you want to use. Then you need to call the machine learning service. Let's say that it's in the cloud and you just need to call that service. So maybe that would be a relatively easy API call, but you still need to do that. You need to format the output, and then you can use the data, or you can use the predictions that you got in your application, or write them back to your database or whatever you need to do. So that would be many steps, and it's not easy. And for that reason, I think most people are probably not really doing this online in their applications. A lot of machine learning is happening offline. So people will go to some desktop tool, Jupyter or tools like that. They will read the data from the database, do something with it, and that's how they would get their predictions, but it would not be happening as part of the application that's sitting on top of that database. And we want to make this easy to use for any application developer, and not just for experts, not just for data scientists. So with Aurora Machine Learning, we basically built an integration into a few of our machine learning services. We started with two of them, SageMaker and Comprehend. SageMaker basically covers any algorithm that you could possibly want to use, because you could use machine learning models that are built by AWS or by partners, or that you build yourself. And Comprehend is a text analysis service where we support the ability to do sentiment analysis. And we'll see how that works in a moment. So basically, you can run machine learning predictions directly from within your application, and you do that using SQL statements. So any application developer that knows how to do SQL queries can basically query for the result of the machine learning algorithm, and you can use that immediately in the application. And the integration between Aurora and those services has been built in a way to work with low latency and to give you immediate results. So this is suitable for low latency use cases, things like fraud detection, or other things where you need to have the results very quickly. And the security and governance, since it's Aurora, it's basically still being done by your database, and you don't need to run it externally. So let's look at how the steps would be collapsed. So if we had 6 steps in the original scenario, we can cut that down to around 3 steps, where the first step would, again, be training the model. If you're training it yourself and you would want to do that step, you can use a newly announced feature in SageMaker called SageMaker Autopilot, which helps you to find the right algorithm, which looks at your data and tries to help you to find which algorithm and which configuration would fit best in order to do predictions on that data. So if you use that together with Aurora Machine Learning, you can basically get a complete set of training and inference or prediction capability for machine learning. And then at that point, once you have the model, you would simply need to run a SQL query that behind the scenes will call the machine learning service and give you the result in your application. So let's look at some examples of what queries might look like. So the first example, in the case of fraud detection, I might be doing e-commerce transactions or credit card approvals, or any kind of scenario where I want to do fraud detection, insurance claims processing, things like that. And I might want to put a database trigger where at the time that I insert the record into the table, which means that the transaction was approved, I could call a function called isTransactionFraudulent. And of course, this is just an example. This is a function that I might want to create that could call a SageMaker algorithm behind the scenes, and I can say which columns I want to pass and which algorithm I'm using. And if it's true, then I roll back the transaction and I don't approve it. Second example would be sentiment analysis. So here I'm using Comprehend, which is an AWS machine learning service that can do sentiment analysis. And in this example, I'm looking at a table of product reviews, and my customers are perhaps entering some text in the review field, whether they like my products, they don't like my products. And I can call a function called detect_sentiment, where I give that column as input, and EN means that I'm processing it in English, and several languages are available. And in this example, I want to look for the ones where the sentiment is negative. So the sentiment can be positive, negative, or neutral. And then maybe I do something with the ones that have a negative sentiment. A third example is in the area of classification. So here I have, let's say, a lot of customers, and I want to try to predict which of them are likely to be big future spenders. So I classify my customers based on data that I have about them in my database. So I might create a function called predicted future spend, which simply calls an algorithm that does that kind of classification, and it gets a bunch of columns from some of my tables. And as a result, I get the predicted future spend, how much we estimate that customer is going to spend in the future, or whether they're classified as a high propensity to spend customer or something like that. Now, we talked about the optimization. I said that Aurora ML has an optimized integration with AWS machine learning services. So what does that optimization look like? So the most important thing is that the rows that you're transferring between Aurora and the machine learning service are not transferred one by one, because that would create very high latency and low throughput. So if I had to go from Aurora over the network to the comprehend service in this example, and then back for one row, and then go there for the next row and back, that would take a long time. So what we do is basically we batch them together so that the whole thing runs much faster. So in the case of comprehend, it can process 25 rows at a time. So what we might want to do in this example, let's say that I'm doing a query where I'm looking for the sentiment of things that people put in my user feedback table, and they said good things, great product, mediocre, I didn't like it. So good feedback, bad feedback, and I want to get the sentiment. What it would do behind the scenes is, as the application is doing the query, what Aurora would do, it would transfer the first 25 rows in a completely transparent way and asynchronously. So it would send the first 25 rows to comprehend. And while comprehend is working on that, which could take a few milliseconds or however long it takes, your database could go on and do other things. It could handle other queries or whatever it needs to do. And once the response is back, it's ready to pass it back to the application. If you had 50 rows in the table, then the application would wait for the query to come back while the Aurora database is sending batches of 25 rows at a time. And as soon as the information is, as soon as all the data is back and we have our prediction ready, then Aurora would respond to the application and give the results of the query to the application. So some algorithms can handle a small, relatively low number of rows, like 25. Some of them can handle thousands or tens of thousands of rows at a time. It really depends on which algorithm you're using, and you can try to configure the batch size as part of Aurora ML so that it is optimized for the algorithms that you're choosing. So if the number of rows is bigger than the batch size, then it will obviously do several batches until all the results are in, and then the query will come back to the application. If the number is smaller than the batch size, then Aurora can actually combine rows for multiple queries and send them all together to the machine learning service in order to save time. So the batch mode works in both directions. Whether the number of rows is big or small, it will optimize for the best batch size for the algorithm that you're using. So let's do a quick demo of what that looks like. So what I have here is MySQL Workbench, and it is connected to an Aurora instance. And what you can see is that we have a table of user reviews or comments, and there are several rows in the table. And what I'll do is I'll just run this. This MySQL kind of points to a database, and it uses comprehend to do sentiment analysis. And you can see some examples where the first row, this is very useful, thank you for writing it, was evaluated as positive and with a high confidence level. And the typical thing to do in sentiment analysis is to query for all the rows where the sentiment was a given sentiment, whether positive, negative, or neutral, with a confidence level above a certain number, where the confidence levels are between 0 and 1. And then you do something with that result. So you can see that some of the negative ones, I'm not sure that this was implemented well, is negative and with a fairly high confidence, because it's not that negative, it's fairly negative. I don't like how this was implemented. It's quite crappy. That's a negative sentiment with 0.999 confidence. So that is very likely to be negative. So that's how you can run sentiment analysis on your data. Highly recommended for scenarios like customer service, user reviews, user feedback. You can deal with them right away as they come in. You don't need to wait to download them and to use any kind of machine learning tool other than just querying from your data. And you can see that the select statement here was pretty simple. I just looked at the common text column, and I looked at the sentiment and the sentiment confidence in my comments table. So that's it for machine learning. And with that, let's just do a quick recap of a few other recent announcements on Aurora in case you missed them. So these are some of the things that we've always had. So we talked about automated updates. It's a managed service, so you get automatic patching of the operating system and the database itself, and very easy scaling, replication, and log management in Amazon CloudWatch. Some of the things that were announced in the last few months are new instance families. So R5, M5, and T3, upgraded from last year's R4, M4, and T2, obviously. So that gives you higher performance and more options in terms of how many CPUs you can use. Auto-scaling storage was 64 terabytes for Aurora MySQL. Some of our other database engines were not yet at 64 terabytes, so they are now. And the same for 80,000 IOPS in terms of I/O to the storage layer. And per second billing is also new for database engines. So you're being billed by the second. There's a certain minimum, but beyond that, you're billed by the second and not by the hour. So might be able to save you some money in some cases. Recommendations are new for Aurora this year. So you might have seen them already for other database engines in RDS. So if you look at the RDS console on the bottom left, there's a new page called recommendations, and that's basically looking at some of the configuration settings for your database and alerting you to anything that looks not optimal or not according to the recommended settings in terms of performance, in terms of security, and other considerations. So things like non-default memory parameters, logging settings that are not optimal, things like that. A few months ago, we added Aurora to the list of supported databases. So now you can see this for your Aurora database, and you can see it for parameter groups. So things like query cache, which is not a recommended feature anymore in MySQL, things like that, you will get alerts, or if you have old database versions, you will see those recommendations, and you can decide to apply the recommendation. You can decide to dismiss it. You might have a good reason to run an old version. You might have a reason to run one instance, maybe in one AZ rather than have multi-AZ. So things like that, you can see the list, and for each instance, you can decide to apply the recommendation or to dismiss it. An additional feature that was added just a few weeks ago is being able to set up access to other AWS services very easily through the AWS console. So the Aurora database can connect to 4 other AWS services. 2 of them, S3 and Lambda, have been available for a long time. And the other 2, Comprehend and SageMaker, are actually new with the Aurora machine learning project or feature. So these 4 services are integrated with Aurora. And when you want to use one of those services, you need to give IAM permissions to the database to access those services. So for example, in the case of S3, you want to allow your Aurora instance or database to read and write from an S3 bucket that you have on S3. And with Lambda, you might want to give permission to call a Lambda function. And with SageMaker, you want to give access to a specific endpoint. And Comprehend is simply a service which is serverless. So you just want to either allow access to Comprehend or not. And it used to take more steps to give permissions to the database to access those services. And we made it very easy to do through this new screen that you see here. So basically all you need to do, instead of selecting an IAM role with all the permissions and the policy inside. All you need to do is to say, I want to connect to one of these 4 services, and I can choose the details of that service. For example, in S3, which bucket I want to access, and then the database will get permission to access that resource of that service, but nothing more than that. So giving permission to one bucket doesn't mean that you give permissions to all of your buckets. So it's also more secure. You can do this at a very granular level. You can say what you want to give access to, and it's just a few clicks. So saves you from a few steps in IAM permissions. Export to S3 is a feature which is getting ready for launch, and we already announced. So basically what that does is allow you to take data from your Aurora backup and export it to S3. You don't need to write any code. It's fully managed, and basically you say which data you want. You give the query conditions for the data that you want to export from Aurora, and it does that from a snapshot of the database or a backup, not from the live database. It's not from the storage layer that we were talking about earlier. It's actually from a backup in S3. So basically, it doesn't really impact the performance of your database, and it's very easy to use. The data is written to S3 in Parquet format, which is a very popular format for data archiving. So that way, you can take the data from there. Now you have it in S3 after you've exported, and you can use it for other purposes. And some of those purposes might be to store it for even longer term archival in a place like Amazon Glacier or Redshift, or you can take it and export it out of AWS completely if you need it in some other place. So all of those options are open. Makes it much easier to read data from your AWS RDS or Aurora snapshots. And then finally, Federated Query is, and you run SQL queries from Athena on multiple data sources, and Aurora is one of them. So basically, you can run a SQL query that will read from Aurora in addition to S3, DynamoDB, Glacier, Redshift, Elasticache, all of these different AWS database services or storage services. You can run that query. It's federated between all of those different data sources, and you can get the result. And you would typically put it in S3, and from there you could get it anywhere. So want everyone to be aware that that's a preview that is started, and you can try to query from Aurora as part of a query of additional or multiple data sources. Okay, so that's it. Hope this was useful to learn what's new in Aurora. These are my contact details, and want to wish everyone a great day. Thanks very much for listening.